Hello everybody, it's Tim Oscar here from Stonebait Games. Now I've recently had a need for a sprite renderer that included an outline around the sprite, such as you can see in this example here, and I couldn't find a decent one out there really that gave me the control I wanted, and also that I could build in shader graph. So I took it upon myself to build my own version in shader graph, and I've got a link to the shader itself in the description, so feel free to grab that. But the basic ins and outs of it are, we have a colour picker here that can change the colour of the outline, and most importantly for my purposes was the ability to change the thickness of the line. So you can see that you can use this slider to increase or decrease the thickness, and just as a convenience I've added a toggle here to turn the outline on and off completely if you want to. So I will walk through the basic design of the shader graph shader and my reasoning for why I've done it this way, and I will also explain the caveats because there are a few that you've got to watch out for, just so that you're aware of the things that you need to be a little bit careful about when you're using this particular shader. Okay, so what I'm going to do to start with is show you a brief demo of what gave me the idea for this particular shader. The built-in UI system in Unity gives you obviously basic text and other stuff, but it also gives you a component that you can add to text called outline. Now I thought it would be useful to be able to add this to sprites, but unfortunately it doesn't actually work for sprites. But I will show you roughly what this does. It does basically what you expect. It adds an outline to the text. But as I was messing around with this, I realised the way it does it is quite neat. It's not sort of super clever or anything, but it's something I realised I could replicate in shader graph quite easily. So you've got obviously the colour, which I'm just going to leave black here, but you've got this effect distance, so you can change the width of the outline on the x and the y coordinates. So if I just increase and decrease these, you can see what effect it has. Does what you'd expect. However, if you take it to an extreme, so let me just increase this to absurd levels, you can see what it's doing. And it's pretty straightforward. All it's doing is taking a duplicate of the text itself, it's rendering it in the colour you want, in black in this particular case, and it's duplicating it 4 times and just shifting it along the x and the y coordinates. In fact, it's doing it along the diagonals in this particular case. But yeah, I thought, well, that should be possible to do for a sprite in exactly the same way. So that's more or less the design that I started with in my head before I started working on the shader. So with that in mind, I will turn off the text and turn back on the sprite. So this I actually grabbed the shader graph example set from Unity Technologies from GitHub, so I can post a link to that in the description as well. But it's not particularly necessary for this case. Just gives you a nice sprite to work with. As you can see, the basic shader itself just has a sprite sheet added to it. This can be a single sprite, doesn't really matter. If I show you where that is on here, it's just this ln run texture sheet here, and I can expand that to show you what's in there. Here you go. It's just a sliced up sprite sheet with a series of animation frames. So that could be any texture, doesn't really matter. And I've just got the toggle for show the outline, the thickness as I demonstrated earlier, and the color picker, and that's it. That's all there is to it. So I will show you the shader in shader graph, which I've prepared here. Now it looks a little bit crazy, and there's quite a lot going on here, but in principle it's actually quite simple, and the reason that there's all this stuff over here is because we're doing the duplication of the sprite 4 times, and that's what each of these represents. But I'll step through each step so you can see what's going on, and you can reproduce this or grab this and fiddle with it and change it however you choose in the future. But the basic design involves an unlit master node, so that's how I started. I just started with an unlit master node, and all we're using here is the color input and the alpha clip threshold, and I've just set the alpha to 0.5. That's pretty standard for doing a sprite renderer. Basically what happens is the sprite has an alpha channel where the bit that you're interested in has an alpha of 1, and the bit that you're wanting to cut off is an alpha of 0, and there's a very quick ramp from 0 to 1 along the edges of the sprite, and so cutting that off at 0.5 gives you a nice clean sharp outline, or at least for the standard sprite renderer. But what I wanted to do was effectively inflate the outline and add a little bit of extra colour to it. So what we do is we start with just a sample texture, which takes the sprite input. So what I did was I added a texture property to the exposed properties here, and that's where we just drop the sprites, the texture sheet or whatever it is we want to render, into that texture slot. That's sampled by this sample texture 2D. And now if you were just doing a standard sprite renderer on its own, all you would do is take the RGB, which is the actual texture itself, and stick that straight into the color channel here, and you would take the alpha channel, which gives you effectively just the alpha. You would take 1 minus that, so that comes down here, which gives you just the black and white. White is where where it's transparent, and black is where it's opaque, and then just pass that straight into the alpha clip threshold. And effectively, what I've done there is I've created a branch based on the show outline toggle. So this show outline toggle is just a boolean that I've added as an exposed property. And if you set that to false, it will just take what I explained there. It just takes the one minus the alpha channel, passes it up straight into the alpha clip threshold here, and ditto for the texture. I've got the show outline toggle here. If that's false, then it just takes the texture direct from the sample and straight through to the color channel there. So that's what's happening if I just turn off this toggle here. It's basically a standard sprite renderer, very simple. However, the addition of the outline requires quite a lot more work, so what I will show you over here is how I go about splitting the texture into 4 extra components and how I then offset them. So I do exactly the same thing as with the standard. So this is what you would render if you just wanted the sprite on its own. However, I'm taking a further 4 samples of that texture. So you can see here I've got 1, 2, 3, and 4. I'm sampling exactly the same way as the main texture, but the only thing I'm interested in is the alpha channel in this particular case. So I just take the alpha channel and I export it out and I add it to the alpha channel of the original. Okay, so I'll show you why that's important later, and you get a composite. So if I'd set the outline thickness to 0, that would basically be just overlaid the two sets of alpha channel on top of each other, which obviously wouldn't give you anything particularly useful at all. But what I'm doing is I'm shifting the UV channel, or the UV of this particular texture, just a little bit to one side. So in this case, so this is what duplicating the alpha channel one time and shifting it very slightly along the x-axis. So I take the UV channel, I take the outline thickness property, and I multiply that with so this is what I call the sensitivity. So this just rescales the thickness to sort of more sensible values. You don't really need to worry too much about what this is doing. It just makes the slider for the outline thickness here a little bit more sensible, so I can do it between 0 and 1. Otherwise you'd be messing around with tiny little values, which doesn't really help you. So just think of that as a sensitivity. You can expose that if you want, but there's not really any point. If you need a bit more control, then feel free to change this to an exposed property. So I multiply that by the thickness that I'm interested in, and shift the alpha channel by adding it on to the red component here. So this is effectively the x component of the UV coordinates. G would be the y component. So I just add on a tiny amount to the x coordinates, shift the UVs, sample the texture, and that generates another UV alpha channel, which I can then add on to the existing alpha channel up here. So I can demonstrate exactly what that's doing by taking this from here. I think this is what will work. Plugging it into this once it's compiled. Save that. Then I'm going to pull this over onto my other screen if I can grab hold of it. There we go. So you can see what's happening here. This is just a single duplication of the sprite, and as I shift it left and right, I increase the line thickness. You can see it's just moving it along the x-axis in the negative direction. So effectively, I'm going to do exactly the same thing, but on the other 3 axes, and then add them all together, basically, so that what we end up with is all 4 of the directions combined together, giving me the duplications in the 4 different directions. So I'm doing exactly the same thing, but this one I'm adding on a smaller quantity onto the y-axis, so you can see it's now into the G channel of the UV space, and just nudging that slightly up. This one's doing exactly the same thing, but now it's doing it on the negative x-axis. So I've got this negate node here, which just takes the line thickness and makes it negative, which nudges it in the opposite direction along the x-axis. And then again, exactly the same thing, taking the line thickness, negating it and nudging it along the negative y-axis, so it's going into the G channel here. So basically what I then do is I add all of these together. So I add the original, the shifted x, the shifted y, the shifted negative x, and the shifted negative y, add them all together into, so this is just a chain of adding here, combine together into this one here. And then what I'll need to do is, what did I do here? So I took this and I need to take it to there. There we go. So that's repairing what the damage I did earlier. I'll just save that. The important thing is, of course, is that when you're adding all these together, you end up with values greater than 1 in the center of each of these sprites. So you just need to add a clamp node here that rescales all of those between the 0 and the 1, so that then you've got nothing that will surprise you later, because you can end up with all sorts of problems if you don't do this clamping. The rest of this stuff is just making sure that everything's correctly scaled, so that we take the 1 minus that, and then that goes into the branch node here that I set up earlier, so that you can toggle the outline on and off, and then that goes into your alpha clip threshold. Now the other thing that we need to do obviously is add the, so what that does is that gives you the alpha space that's shown by the sprite renderer. So that effectively just expands the extent of the sprite in all 4 directions, but that doesn't give you the actual coloured outline. So in order to add that in, we take exactly the same clamped alpha component here, colour it in using the colour property that I've added up here as an exposed property, the outline colour, and then I subtract away the original alpha here to give me just the outline. So this now gives me just the 4 shifted versions of the sprite with the original subtracted away, giving me just the outline. Clamp that again, because you could still have issues with the value being greater than 1 or less than 0, so you don't want to have that problem. Clamp it, then add it onto the original sprite, which I'm just multiplying by the alpha again here to make sure that I get black along the edge. Add those together, goes into the branch node as before, and then all of that goes into the color node of the master lit, the color channel of the unlit master node here. So with all that in mind, hopefully you followed along with that. It's a bit, like I say, it's a bit complicated, but once you understand each component, it should fit together neatly, and ultimately you get the finished shader, which I demonstrated earlier. There we go. So you can see that if I expand, so here's the start of the caveat section. This is all fine and well, but obviously you can see the issues. If I crank this up quite high, you end up with little notches in the corners. So for example here, and in the arms here, and in particular where the hair is all spiky, you get this weird, slightly odd effect here. So this is why I've provided a slider here rather than letting you change it from any value you like, because typically you probably want to keep this reasonably small, somewhere up, maximum of up maybe about 0.4, 0.3, something along those lines. So that works fine, but you can see you still get a few little weird glitches where you've got some quite tight breaks in the texture here. You've got you can see the sort of slightly spiky nature of the hair, and you can still see very slightly there's the notches taken out of the knuckles. You could, if you wanted to, slightly smooth those out by doing another 4 of these. You could duplicate these, stick them down here, continue the chain of addition here, but instead of adding to the X or the Y on its own, you add it to the X and the Y, and that would move your sprite in the diagonal directions. So you could effectively have eight duplicates of the sprite and shift them, top, bottom, left, right, and then the 2 diagonals, top right, top left, and bottom right, and that would give you a slightly more smooth outline, and you'd properly account for the corners, for example. But it means that you're doing more calculations, so it's up to you whether you add that in or not. I haven't bothered because, for my purposes, this is probably fine. If I find I've got issues later on, I can always add that in. So there are 1 or 2 more things to be made aware of. If I put this down to 0, you would normally expect the outline to disappear. However, we still have this 1 pixel outline. I'm not 100% sure why that is. I think it's because we're having to do some clamping of the textures in this part here. It might be possible to get rid of that. I haven't played around too much with that, but this is why I basically provided a toggle, because if you wanted it without the outline, obviously turn the toggle off. But if you do want an outline, well, it doesn't really matter. So a 1 pixel thick outline, you're probably not going to want anything smaller than that. So setting this to 0 and having the outline on gives you just a very subtle effect. But you can play with this as much as you like. If you didn't want this toggle, just to remove these 2 branch nodes here, that would work just fine. It means you're not doing this extra calculation if you don't need to. If you want just a standard sprite renderer, well, that's easy enough. You don't need to worry about that. You can just use a standard sprite renderer and then substitute in the outline renderer if you prefer, or you can just use this toggle. That's fine. I don't really mind. Do what you like. So one final thing to be aware of, because this is actually an animated sprite, I will just show you something that can catch you out, and I will explain what a possible solution to that. If I show you the frames of this animation, there's a couple of frames where you get some very odd glitches. There you go. So you get a little bit of green up there, and also I think there's another one. Yeah, there you go. There's another little glitch here. If I bump that up the outline, you can probably get a better idea of what's going on. So the reason for this is you can see. Let me show you on this frame here. You can see the outline is being chopped off because the sprite is obviously in a square image here, but the outline has reached the edge of the visible sprite, but it's bleeding over into the next frame. So this is actually the toe from this frame showing through on this frame. Now, there's a very good reason for that, and I will show you. If I show you the actual texture, you can see exactly why this is happening. Basically, the way I'm I'm duplicating this entire sprite sheet and then nudging it left, right, up and down for those duplicates. But you can see that if I did that, make the outline too thick, here we go. So you can see that in this particular example, this foot here, the outline will be bleeding over into this frame, which is exactly what was happening in that demo in this particular example here. So if you make the line too thick, it's going to be bleeding across. Now the solution to that is to basically redo your sprite sheet so that there's a little bit more space, a little bit more of a buffer around each of these sprites, so that it accounts for the thickness of your outline. It might mean that you have to sort of take. If you just took this sprite image, for example, you would be limited to how thick you could make the line. But if you were happy to break this up, expand it on in the sort of the full texture, just give it a little bit of buffer space between each of these separate images, reslice it, and then you should be fine. So that's how you'd get around that. So that's pretty much all I have to show you for today. I think I've covered all of the caveats. If you find any others, please let me know. Take the shader, mess around with it, change it however you want. I'll make it available in the description. And otherwise that's everything, and if I have anything more interesting to show you some other time in the future, I will make another video. But in the meantime, thanks for watching, and have a good day.